Welcome back to the Mastering Algorithms and Data Structures in PHP series. Today, we're diving into an advanced data structure called graphs. By the end of this lesson, you will know how to represent graphs using two popular methods, the adjacency list and the adjacency matrix. You will also learn how to implement these graph structures in PHP and how to manipulate them. A graph is a collection of nodes called vertices and edges that connect these nodes. Graphs are used to model relationships between different entities, making them extremely useful in scenarios like social networks, transportation systems, and even recommendation engines. One way to represent a graph is with an adjacency list. An adjacency list uses an array or a map where each key represents a vertex, and the value is a list of all its neighboring vertices. This representation is efficient for storing sparse graphs, where there are relatively few edges compared to the number of vertices. In this example, we've created a simple graph class that uses an adjacency list to represent the graph. We can add vertices and edges and displays a list of connections for each vertex. Another way to represent a graph is by using an adjacency matrix. An adjacency matrix is a 2D array where the rows and columns represent vertices, and the values indicate whether an edge exists between those vertices. This representation is ideal for dense graphs where most vertices are connected to each other. In this example, the graph matrix class uses a 2D array to represent the connections between vertices. We add edges and display the adjacency matrix, showing how each vertex is connected to the others. Let's compare the adjacency list and the adjacency matrix. Adjacency list is more space efficient for sparse graphs, while adjacency matrix is better for dense graphs where edge lookup needs to be done quickly. In addition to representing graphs, it's important to understand how to traverse them. Two common traversal methods are breadth first search (BFS) and depth first search (DFS). BFS explores a graph level by level, starting from a given vertex and visiting all neighbors before moving on to their neighbors. DFS explores as far as possible along a branch before backtracking. We will explore these traversal algorithms in detail in upcoming lessons. Graphs are incredibly useful in real-world applications. They can represent social networks where people are nodes and friendships are edges. Road networks where intersections are nodes and roads are edges. Or web page link structures where web pages are nodes and hyperlinks are edges. To summarize, we covered how to represent graphs using the adjacency list and the adjacency matrix in PHP. The adjacency list is ideal for sparse graphs, while the adjacency matrix works well for dense graphs. Understanding these representations is fundamental to working with complex networks and relationships in your code. Thanks for watching. In the next lesson, we'll explore graph traversal algorithms, including breadth first search and depth first search. If you enjoyed this video, please like, comment, and subscribe for more content. Check out the full code for this lesson on GitHub, and I'll see you in the next video.